As the James Webb Space Telescope continues to peer into the primordial past, its revelations grow more baffling and more profound. With each newly imaged galaxy formed just a few 100 million years after the Big Bang, scientists are faced with an unsettling realization. Something unseen must be at play in the early universe, and that something might be dark matter. For decades, dark matter has loomed as one of the universe's greatest mysteries. It doesn't emit, absorb, or reflect light. It can't be touched or directly seen. Yet its gravitational influence is undeniable. Galaxies spin faster than their visible mass should allow. Cosmic structures form in patterns that betray the presence of a hidden scaffolding. Dark matter is the invisible glue holding the cosmos together, and it may also be the secret accelerator of galactic birth in the early universe. Here's the idea. While ordinary matter, what we're made of, was still struggling to cool and coalesce, dark matter may have already been clumping into dense halos. These halos, though invisible, exerted immense gravitational pull, acting as cosmic wells into which ordinary matter could fall. Once trapped, that matter began forming stars and galaxies, faster and more efficiently than previously imagined. This theory isn't entirely new, but the galaxies detected by JWST give it fresh urgency. Some scientists now propose that ultra-dense dark matter halos formed shockingly early, creating gravitational environments ripe for accelerated star formation. These halos might not just support galaxy formation. They could trigger it at warp speed. But there's a twist. If these dark matter halos were too dense or too numerous too early, they'd have left imprints in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Yet current observations don't show such distortions. That forces theorists to walk a tightrope. How can dark matter be active enough to build galaxies early, but subtle enough not to betray itself in the background glow? Enter new models. Some physicists are now exploring the idea of warm dark matter, particles lighter and faster moving than the traditionally hypothesized cold dark matter. These warm particles might have created smoother, faster-forming structures, avoiding the telltale clumpiness that would disturb the cosmic background. Others suggest self-interacting dark matter, in which particles of dark matter collide and scatter, changing how they distribute gravitationally. In simulations, these properties can reproduce galactic formations that resemble JWST's early discoveries without breaking the observable universe's rules. Still, these ideas remain theoretical. No one has directly detected a single dark matter particle. The Large Hadron Collider has come up empty. Deep underground experiments have yielded only silence. But the cosmos is speaking, loudly, and it's telling us that whatever dark matter is, it plays a critical role in shaping the universe. And what about dark energy, the mysterious force accelerating the expansion of the cosmos? While dark energy dominates the universe today, it's thought to have been less influential in the early universe. But what if that's wrong? Some fringe hypotheses suggest that dark energy may have had surges of activity, brief eras of repulsive force that shaped large-scale structure far earlier than we expected. These surges could have accelerated matter away from voids and funneled it into dense regions, catalyzing the birth of massive galaxies. Alternatively, dark energy may not be a constant at all. Some models propose it evolves over time, or space, like a dynamic field that pulses with varying strength. If such pulses occurred shortly after the Big Bang, they could explain the unusually rapid growth of cosmic structures we now observe. The truth is, we are just beginning to grasp how the invisible universe shaped the visible one. The galaxies that Webb has revealed aren't just outliers. They're signposts, clues to a deeper architecture of existence. One held together not just by gravity and atoms, but by forces and particles we have yet to comprehend. This is the frontier where physics meets philosophy, where questions outnumber answers, where models strain and mystery thrives. At Infinity Beyond, we believe that these are the most thrilling moments in science, when nature teases us with evidence that reality is stranger, richer, and more wondrous than we dared to believe. In the next segment, we'll dive into alternative cosmological models that challenge the standard Big Bang narrative. Could the universe have started differently than we think? Are there other explanations for the early galaxies besides dark matter? And what if the entire history of the cosmos is due for a rewrite? Stick with us. The journey through the unknown has only just begun.